Hi, I'm Cameron Tonks, and today we're talking about conductors, insulators, and charges. There are two charges in our world, positive and negative. And each atom has both positive and negative. The nucleus, being positively charged, is surrounded by negatively charged electrons. And because positive and negative forces attract, this allows the electrons to remain close to the nucleus. And we also know that like repels like in forces, as described by using two balloons rubbed against my hair to give them the same force, the same net charge on each balloon. We'll see that they are repelled by one another. Having known charge leads us to current. And current is the flow of charge, or electrons, through a conductor, which we'll talk about later. You can think of it as water going through a pipe, or the rate of water rushing through a pipe. Current is how many electrons are flowing through a wire, for example. Now, with our knowledge of current, we can begin to understand the difference between a conductor and an insulator. Now, any material or substance can be defined by its ability to allow the flow of electrons. Conductors conduct or allow current to flow, insulators do not. This distinction is best made at the atomic level. Conductors are made of elements that have free-flowing electrons. Many conductors are metal, and metal is known to have a sea of electrons that allow electrons to be shared amongst atoms. Insulators are made of materials or elements that have atoms that tightly bind to their electrons, not allowing this flow of electrons through them. And the distinction is made when a current is induced between an insulator and conductor. Now, the atoms within a conductor allow the free flow of electrons, and the flow of electrons, or the current, bounce from atom to atom and make it through the conductor with very little resistance. Now, an insulator is different, as the current is induced and bounced from atom to atom. Because they're tightly bound, there's much more resistance, and it stops the current from flowing to go to the other end. We find many examples of insulators and conductors in our world, in glass, rubber, plastics, and wood, and many metals as conductors, such as gold and copper, like copper wires, as we'll see, and salt water conducts very well. In a common wire, we see that it's composed of both a conductor and an insulator. Now, the copper wire allows the current to flow from one end to the other, and the insulator prevents that current from going anywhere we don't want it to. Now that we know what current is, insulators and conductors, we can understand how a charge can be given to a conductor. Now, the first one being very simple, one conductor having a net negative charge is simply connected to a neutral conductor, equally distributing the charge between the two. Now, friction, a net charge can be induced on an insulator by friction. As my hair rubs against this balloon, charge is transferred from my hair to the balloon. And now, since the balloon has a net charge, it can be attracted to a neutral object, such as a wall or a board, as you see here. A net charge on a conductor can be induced. In this instance, two metal balls are in contact with one another. And you bring in another conductor that has a net charge on it, in this case a negative charge, and this polarizes the forces between the two metal balls. The like forces repel from the negative charge, and the opposite forces attract. And there you separate the two balls, and you have an induced charge on each metal ball. And there we have insulators, conductors, and charges.